In this video, you will learn how to calculate vector products, also known as cross products, and how to use them to find the area of a parallelogram or triangle in space. While the dot product of two vectors is a scalar, meaning a number, the cross product is a vector. Here are some facts about cross products. First, the cross product between two vectors is normal, remember that means perpendicular, to the plane that's defined by vectors A and B. The direction of the cross product is the same as the direction your right thumb would point if your right fingers curl in the direction from A to B. And by that I mean if you were to put the side of your hand with the pinky on vector A with your wrist at its beginning and your pinky at its pointy part, and then curl your fingers in the direction of vector B, your thumb is either going to point up when you do that, or it's going to point down. If it points up, we say it's positive, and down, negative. The magnitude of the cross product, which remember you're going to find by taking the square root of the squares, the sum of the squares of each of the components, is the same thing as the magnitude of A times the magnitude of B times the sine of the angle between them. And that means that the magnitude of the cross product equals the area of the parallelogram determined by the two vectors. And to see why that's so, here are two vectors, and they make up two sides of a parallelogram. If I want to know the area of that parallelogram, remember that it's base times height. If the base is the magnitude of vector A, the height is that red dashed line that you see in the figure. And that height is the sine of alpha times the magnitude of vector B. So if I do the magnitude of vector A times the magnitude of vector B times the sine of theta, I will get the area of that parallelogram. And of course, if I want the area of the triangle determined with two sides, vector A and vector B, that's just half of the parallelogram. All right, so let's consider some specific situations. In the upper right corner, I put the formula that we got from the previous slide, that the cross product has a magnitude, and that magnitude can be found by doing the magnitude of A times the magnitude of B times the sine of the angle between them. So my first question is, what is the value of A cross A? In other words, a vector cross product with itself. Well, remember that the magnitude of the cross product is the magnitude of the first vector times the magnitude of the second vector times the sine of the angle between them. But if the vectors are the same, then the angle between them has 0 degrees. And the sine of 0 is just 1. It is 0, sorry. The sine of 0 is 0. And so the magnitude of A cross A is 0. And that means you have a vector with no magnitude. In other words, a 0 vector. Now, vectors, remember, the cross product of two vectors will be perpendicular or normal to the plane that they're on. So if you look at the axes with the unit vectors I, j, and k, if I want I cross j, I'm going to get a vector that's perpendicular to the two of them. In other words, k. The only question is, what's the magnitude? Well, the sine of the angle between I and j is 90 degrees. That's how we set up the axes. And that means the magnitude is 1. I have 1 for the magnitude of I, it's a unit vector, 1 for the magnitude of j, also a unit vector, and the sine of 90 is also 1. 1 times 1 times 1 is 1, and I have a magnitude of 1 in the direction of k. Similarly, I can find that j cross k, also at 90 degrees from each other, is equal to vector I, and k cross I equals vector j. Notice that I went clockwise around the setup of the picture, and that tells me what's next. If you rotate the other way around the circle, in other words, you do j cross I, or I cross k, or k cross j, you're going to get the opposite sign on the product, on the cross product. So K cross I is positive J. I cross K is negative J. And what that means is cross products are not commutative. They have opposite signs if you switch them. An easy way to remember this is to write down the letters IJK twice. So write IJK, IJK. If you move from left to right, you're going in the positive direction. And if you move right to left, you're going in the negative direction. So if you have a situation where you have I cross J, you can look at the first three letters and you know that I cross J is going to equal positive K because you're moving in the right. If, on the other hand, you wanted K cross J, now you're moving left and it's going to equal negative I. Similarly, if you wanted K cross I, it will equal positive J. But if you do J cross I, because you're moving to the left, it's going to equal negative K. And finally, if you do J cross K, you'll get positive I. But if you do I cross K, you'll get negative J. All right, your turn to try. What is J cross K in terms of the unit vectors I, J, or K, positive or negative? You're going to choose an option. All right, hopefully you got that that was vector I. All right, try this one. J cross I. That should be negative K. How about I cross K? That's negative J. How about K cross itself? Hopefully you didn't get tricked by that. That's the zero vector, so it's just zero. And finally, what's K cross I? And you would be correct if you said J. All right, so how do we calculate the cross product when we're not interested in unit vectors? So suppose I have two vectors, one is vector A and the other is vector B, and I would like to find the cross product. Well, this is just plain old polynomial multiplication. You're going to multiply vector A times vector B. And you're going to do it with the distributive property. You remember 2i times 5i, 2i times j, 2i times 4k. The only thing you have to be careful of is because vector multiplication is not commutative, you can't just write the letters in any order. You have to write the first one first and the second one second. If you do that, you're going to end up with this. I'll give you a moment just to look at that so you can convince yourself that I did distribute correctly. You'll also notice that I wrote the vectors in bold instead of putting the arrows on top because the arrows were getting too crowded on my presentation. All right, so the next thing I have to do is I need to simplify. For example, I know that 10i squared, well, I squared, when you're talking about vector multiplication, is 0. I also know that if I multiply vector I times vector j, I get vector k. So I went through and I simplified each of those, right? And I made sure I took the positive and negative values into consideration. Now I'm going to combine like terms, and I end up with the cross product of vector A and vector B. That's the long way. It always works. It's a bit tedious, and you have to be careful when you're trying to simplify what vector I times vector j is and what j times k, etc. So now I'm going to show you a shortcut way. All right, so for the shortcut way, you have to start by setting up a little matrix. And that matrix's top row is going to have vectors I, j, and k. The middle row will be the first vector that you're multiplying, and the bottom row will be the second one. Remember, order does matter. Then what you're going to do is you're going to find the determinant of that 3 by 3 matrix. Now, you remember how to find the determinant of a 2 by 2 matrix because we did that by hand before, but we let your calculator do the 3 by 3. So watch carefully as I show you how to do it. The determinant is made up of 3 parts. You're going to start with the vector I, and you're going to write that down. And then you're going to find the cross product of the rows and columns that I is not in. So cross out the top row, cross out the first column, and look at these two numbers, the 3 and the 4. Multiply those, and then multiply the other diagonal and subtract. So you are finding the 2 by 2 determinant of the 2 by 2 matrix that's left after you cross out the top row and the first column. All right, that's the first part. Now we're going to look at J. Notice the sign on J is negative. We alternate. So the first one is positive, the second is negative, the third is positive. If this were a 4 by 4, because you had vectors in 4 space, then the next one would be negative, etc. Now cross off the row and the column that J is in and look at the remaining numbers. You have a 2, a 10, a 5, and a 4. Multiply the 2 and the 4, multiply the 5 and the 10, and subtract them. All right, now we're ready for K. Positive again. Cross out the row K is in and the column K is in. You're left with a 2 by 2 matrix of the numbers 2, 3, 5, and 1. Multiply the 2 and 1, multiply the 3 and 5, and subtract. And when you're done with that, you will get your cross product. And you'll recognize, I hope, that that's the same thing we got when we did the whole thing out the long way. All right, try one. Multiply this out the long way. All right, so here's the answer. I'll give you a moment to look at it. All right, not surprising. Now try it the short way. Use the determinant. And here's the answer. I'll give you a moment to look at that as well. All right, so now that you know how to find a cross product, let's use it to find the area of a parallelogram that's determined by two vectors in space. Now these two vectors have complete positive components, so this is a parallelogram that is located in the first quadrant out of the 8 that you would get in space. Now remember that the magnitude of the cross product equals the area of the parallelograms determined by the two vectors. So the first thing I need to do is find the cross product. All right, I'm going to do this the short way. So here is my matrix, and there is the work that I will do. And here's what it equals. So now that I know the cross product, I need its magnitude. And you'll remember how to find the magnitude. That's just the square root of each of the components squared, added up, and it's about 80.29. And that means the area of the parallelogram is about 80.29 square units. Now, if I wanted to know the area of the triangle that is formed by vector A and vector B, and if I connected up where their two arrows point to create the triangle, that's just half the parallelogram. And so it would be exactly half of 80.29, or about 40.145. All right, so that's it. That's the presentation. This presentation is in Schoology, so if you'd like to go back and look at any of the parts, you may. I would like you to do these problems. There are 4 of them in your book, and submit them on Schoology. Have a great day.